The second part for the lecture 5 is the topic is the hydrostatic force on the curved surface. Okay, assume that this is a curved surface is the arch dam base or ฐานของเขื่อนโครง okay, and we can write equation between relationship between x and z. Okay, based on this equation, it is a parabola equation. Okay, and if we write the pressure distribution on this surface, we can write on this. It's like this shape is pressure distribution acting on the surface. Okay, and next we start to find equation at this point about the depth is h subtract z. So pressure at point at this depth is equal to p gamma h subtract z, and dF is equal to pressure times the area. In this case, the area is equal dA is equal to W times ds. Okay, that is the ds. Okay, and for the dz, dx, in this case we can separate df into dfx and dfy and dfz. So dfx is equal to df f sine theta cos theta. So we start to this point fx is equal to df sine theta, and next we substitute the df in this equation, and that we got this, and for ds sine theta is dz, so we just substitute dz in this equation, and we do integration for fx from integration of dz from 0 to h. Okay, so finally we get the equation of the fx is equal to 1/2 gamma times width and h square. Okay, that is from the integration, but we can do from the prism concept. Okay, start from fx is equal to the average of pressure at this point and this top point, average of pressure. So divided by 2 and times the area is h times w, so equal to 1/2 gamma w h square. So that is the same for this equation for fx. And for fx, we can prove that similar to the sloping wall and vertical wall is independent of the slope and theta. So in this case, even the vertical wall, inclined wall, fx1, fx2, fx3, you can find that this is the same. Okay, is independent to the slope and theta. Okay, for the horizontal, for the fx acting on the wall. Okay. The next is what is the fz? Okay. Vertical component fz equal to fs cos theta. So next we substitute df in this equation, and next we substitute z in this equation, and start to do integration of dx from 0 to fx 0 to a. Okay, integrator of dx, and finally we can find the fz is equal to 2/3 of the gamma wha. Okay, in this way, if we can derive this fz from the prism concept as well, if we know the volume of the hash area, for example, this area. If you know the volume of this area, so it's equal to 2/3 of AHA times HN W. Okay, if we know this volume. Okay, so Fz is equal to volume times rho g. So we got 2/3. So gamma times the width times HA. So what is we already got is the same as the equation 2. Okay, the same as this equation. Okay, the next we want to find the location of Fz acting on acting on the surface. So in this case, we know that this is Fz, and we want to know what is the x bar, location of the. So we have to, the force Fz should be acting at the centroid of this area. Okay. So the next we do the Fz times x bar is equal integration of the Fz times x. And next we substitute the F from above equation, above equation, and do integration. Okay. And for dz cos theta is a dx. Okay. And we can do integration, that we can prove that the xa x bar equal to 3 of 8 of area of length a, that is the centroid of the hash area that we learned from the static as well. That is